Hello everyone, welcome back to Limonco 21. On this occasion, we will create a simple project using Golang with Prisma ORM. In this tutorial, we kickstart a Golang project by initiating it with Go mode init and creating the main file. Following that, we build a simple print server for a quick test run. Once the server is up and running, we proceed to add dependencies for reading a env file. After loading the file, we print the application's port for verification. We create an HTTP server instance named server with specified configurations such as the server address 8080, the request handler, routes, and timeout values for reading and writing. The server is started using the listen and serve method. If any error occurs during the server startup, it is captured in the server error variable. If there is an error, the program panics, meaning it stops execution and prints the error message. This ensures that any critical issues during server startup are immediately addressed. Next, we organize our project by creating a helper folder and adding an error panic file to handle errors and panics effectively. Moving forward, we enhance our project by implementing read and response JSON functionalities. Initially, we create a function to read the JSON request body with input parameters of HTTP request and interface. Additionally, we add another function to write JSON responses. We then introduce a data folder where we create request and response classes. First, we add the web response as a class to be utilized later in the project. To extend the capabilities of our project, we integrate the Prisma Golang library by adding a Prisma folder and including a schema, Prisma file. Now we create data source. The data source block specifies the database source, indicating that the project uses PostgreSQL as the data provider. It fetches the database URL from the environment variable. After that, create generator. The generator block generates the Prisma client for Golang using the specified provider. So now create model post. The model block defines the data model for the post entity. It includes fields such as ID, a unique identifier, created at and updated at, timestamps for creation and update. Title. The post title, published, a flag indicating if the post is published, and description. The post description. Before we begin, we need to generate the Prisma library by executing the command go run github.com/stebchen/prisma-client-go generate After that, we create connectub function, serves the purpose of establishing a connection to the database using the Prisma client. Inside the function, a new instance of the Prisma client is created using the db.newClient function. The code attempts to connect to the database using the client.prisma.connect method. If an error occurs during this process, the function returns nil and the encountered error. If the connection is successful, an informational log message is generated using the log.info.message connected to database statement. The function returns the Prisma client and a nil error if the connection is successful. Now let's create foldem dol. an add post model. The post struct is a composite data type that encapsulates various attributes associated with a post in our application. This post struct serves as a blueprint for representing post-related data in our Golang application. Next, we create Repository Layer Add Post Repository. The Post Repository interface outlines a set of methods that any concrete implementation of this interface must provide. This establishes a consistent contract for interacting with a repository managing post entities. Save persists a new post entity in the repository. Update modifies an existing post entity in the repository. Delete removes a post entity from the repository based on its unique identifier. FindByte retrieves a post entity from the repository based on its unique ID. Returns an error if the post is not found. Findall fetches all post entities stored in the repository. Now it's time for us to implement the first repository. We create a post-repository impl structure. The new post-repository function is a constructor that creates a new instance of the post-repository impl. It takes a Prisma client as a parameter and returns an object that satisfies the post-repository interface. This function enables the injection of the database client, allowing for better testability and flexibility. The delete method is defined within the post-repository impl struct, and it adheres to the post-repository interface. The core of the delete method involves interacting with the database using Prisma. The following code initiates a delete operation for a specific post record identified by its post ID. To ensure robust error handling, the code utilizes a helper function, error panic. Finally, the number of affected rows resulting from the delete operation is printed to the console. The Findall method is defined within the post-repository impl struct. Now add query using Prisma. Don't forget put error handling. After retrieving the raw post records, the code processes each record to extract relevant information and create a slice of model.post instances. The method concludes by returning the slice of model.post instances representing all post records retrieved from the database. Next step, add implementation FindBid. The steps are still the same as above. The only difference is the query. Next, we will implement, save and update. The steps are almost the same, only the query is different. Okay, next we go to the service layer. First, we create the CRUD interface. Before that, we first make an input request and response JSON. When a client requests information about a post, the server can use the post-response struct to construct a response payload containing the necessary details of the post. Post-create-a-request struct is a data structure in Go that defines the format of the payload expected when creating a new post. It consists of 3 fields: title, published, and description. The title field is defined as a string with validation constraints, specifying that it is required and must have a length between 1 and 100 characters. The published field is a Boolean indicating the publication status of the post, and the description field is a string providing additional details about the post. Next, we create a post update request. Just copy the coding from before. Just add the ID attribute. Okay, let's go back to the post service interface, because we have made a request and response. Now we enter it as a parameter in the post service interface. Next, we will proceed with the implementation of the post service. Similar to the repository, let's first create the post service impulse struct, which includes a reference to the post repository within it. Subsequently, we will implement the CRUD operations defined in the interface. Beginning with the create method, this function in the post service is responsible for persisting a new post. Prior to executing the save operation, we perform a mapping of the request data to the post model. Moving on to the delete method, it handles the removal of a post based on its unique identifier, posted. This method utilizes the post repository to execute the deletion. For the findAll method, the process is similar. We execute the repository's find all operation and then map the results to the response structure. The findByte method follows a parallel approach, executing the repository operation and subsequently mapping the retrieved data to the response structure. Finally, the update method, akin to the create method, involves mapping the request data to the post model before executing the update operation. This structured implementation ensures that each CRUD operation adheres to the defined contract of the post service interface. It promotes code readability, maintainability, and consistency across the service layer. Next, we make the controller. The first stage is to create a post controller struct with a post service in it. In the post controller, we have implemented the create method to handle HTTP requests for creating a new post. The function starts by creating an instance of postCreatorRequest to represent the data sent in the request body. This request data is read from the HTTP request using the utility function helper. Read request body, ensuring proper parsing and mapping of the request body to our request struct. Following this, the create method of the post service is invoked, passing the postCreatorRequest and the request context for proper handling and execution of the post creation operation. After the creation operation, we construct a web response containing information about the HTTP response. Such as the status code, 200 for success, and status message, OK. The response payload, data, is set to nil, since the creation operation typically does not return specific data. The rest is done the same as the create method. New router function is responsible for creating and configuring the HTTP router for our application. We start by initializing a new instance of the HTTP router, which is a lightweight HTTP request router. This block defines a simple route for the route path / that responds with a welcome home message. The GET method indicates that this route should handle HTTP GET requests. These lines configure routes related to posts. Each route is associated with a specific HTTP method, GET, POST, PATCH, DELETE, and corresponds to different actions in the post controller. The posted parameter in the route path is a placeholder for the actual post ID. Finally, the configured router is returned from the function, making it ready for use in the application. Now we add the repository service controller to the main file. Before running the application, we will migrate and deploy Prisma into the database. You can type commands, like on the screen. If you look at the database, the post table has been created. Next, we try to run it, and the result is successful. Now we will do the entire API CRUD test. First, let's try find all API. Okay, it's working well. Now let's try inserting post data. It's already running too. If we check the database, the data has been entered. Let's try entering one more data. Next, we update the post in the database. Now we try to delete the data. Oh, it turns out there was a writing error for the delete method. Let's fix it first. We tried again, and finally it worked.